So we divide. So when I have one log minus another log, you combine them with subtraction. So it's log base 4 of 1, or combine them with division, sorry. Divided by x plus 1 equals 1. Okay, now I have it set up so it's that one logarithm equals a number. So switch to exponential, what do you get? You guys get 4 to the 1 equals 100 over x plus 1. There is base though, it's 4. Let's see, 4. All right, so 4 to the 1, that's just 4. So I'm going to write it as a fraction. So 4 over 1 equals 100 over x plus 1. And that allows me to cross multiply. So I'm going to have 4 times x plus 1 equals 100 times 1, so just 100. You can do this 2 different ways. You can distribute. So 4x plus 4. Or you can just divide the 4 over. I like that way the best. So let's divide the 4 over. So I get x plus 1 equals 25. So x equals 24. So your answer is 24. Okay, there was one on your homework where it was real simple. It just said like log base 5 of 2x minus 1 equals log base 5 of 3x plus 4. I don't remember the exact problem. What would you guys do if you had something like that? Yeah, just get rid of the log base 5s. Do you guys see that? So Mike said you just get rid of the log base 5s because you have log base 5 of something equals log base 5 of something else. So those two things must be equal to each other. Yep. And then the other thing that I like to mention is back when I first taught this, I don't know, some of my students were like, can't you just raise both sides? Which you can. Yeah, Abby, do you have a question?
Yeah, like what if it was log 5 2x minus 1 equals log 2?
Yep, then you can't do it.
Can you cross out?
Nope, can't do it that way then. That would be a hard one. You'd have to do like change a base on both of them and then all kinds of crazy stuff. All right, so here, so this is what some of my students like to do. They like to think of it as 5 raised to this whole left side of the equation equals 5 raised to the whole right side, and that's why those are canceling. So you can think of that. Notice how if you thought of that here on number 2, just see where I'm pointing, what would get rid of the log base 4? 4 raised to it, right? If you did 4 raised to both sides, then 4 raised to the log base 4 cancels. You're left with 100 over x plus 1 equals 4 to the 1. That's where we got that. So it's the same as just switching it. It's just a different way to think of it. Some people hate that, though, because they're like, why are you raising the whole side of the equation? I don't understand. All right, so number 3, it says log base 5 of x to the 4th equals 8. Okay, 2 ways to do this. Well, there's lots of ways to do this, but we're going to talk about both. What do you guys think is an easy thing to do?
5 to the 8th.
Yep, so that's one way. You can say 5 to the 8th equals x to the 4th. That's going to be the second way I do it. Anybody see another way? Yeah, you can bring the exponent to the front. Good. So Jasmine says bring the 4 to the front. So I have 4 log base 5 of x equals 8. That was a rule of logarithms that allowed us to do that. So now I have 4 times log base 5 of x, so I'm going to divide the 4 over. So I get log base 5 of x equals 2. So I divide it by 4. So I say 5 to the 2nd equals x.
Where'd you get the 2?
So x is 25. I divided by 4.
Oh.
So x equals 25. I did all that in my head. I didn't need a calculator at all. You guys can do that. That's not hard. Second way. So this is what Carolyn was saying, which is completely right. But if you didn't notice you could pull the 4 to the front, you would say 5 to the 8th equals x to the 4th. And then you'd be like, 5 to the 8th. So if you put 5 to the 8th in your calculator, you get 390625 equals x to the 4th. So then you take the 4th root. I can do this in another color. which I don't know how to do the fourth root of that in my head. So I'd raise it to the 1/4, and you get 25. So x equals 25. You would actually, since you're taking the fourth root, you'd get plus or minus 25. But if you check a negative number, if you try to take the log of a negative number, it's not going to work. Oh, so this one actually, since x is a fourth, wonder if negative 25 does work then. All right, so you don't want to do it that way, because that's too many big numbers, so just do it this way. All right, next up, so number 4. So how do I combine those two logarithms? Can't raise it to the 12th, no.
X, no.
Did it, Caroline?
X times X
Together.
and then you combine them.
X times x plus 1 equals 1, with a little 12 down there still. Yep, Carolyn said it.
Why can't you bring the 12 to the front?
It's not an exponent, it's a subscript. It's a base.
But it's even how come in number 2 you put the 4 out? You did 4 to the 1.
What are you talking about?
12 to the 1.
Number 2, I did 4 to the 1. Oh, I combined them first, right? You need to combine first. Combine your two logarithms first, and then you can do 4 to the 1 equals so on. Okay, so now that I've combined them, let's write it so I see log base 12 of x times x plus 1 is x squared plus x equals 1. So Isabella, what do I get? 12 to the 1 equals x squared plus x, right? Switch to exponential. 12 to the 1 equals what's left? X squared plus x. All right, subtract your 12 over, so I have x squared plus x minus 12 equals 0. Factor. So I get x minus 3 times x plus 4. So I get x equals 3, and I get x equals negative 4. Okay, I'm going to plug those into my original and check. Now, if you guys check log base 12 of negative 4, here's what happens. That's the same as log of negative 4 divided by log of 12. Do log of negative 4 on your calculator. What happens?
Error.
It says error. It says non-real answer. The reason is because log functions, did you guys remember they had an asymptote down there? Like on the x equals 0? So there were no negative numbers that you're plugging in for x. So you can't plug a negative into a log. So negative 4 is not going to work. 3 is the only one that will work. So that's your answer. Now the question Isabel just asked is, will negatives ever work? Yeah, if your original said log of negative x, then if you get x equals a negative number and you go back and check, it's a positive number, right? So you always got to think about what it is that you're plugging into.